so I need to start immediately. Basically, this is a joint research, joint collaboration between three universities from UGM in Yogyakarta, Binus University, the place I'm teaching right now, and Universitas Pertamina. I think some of our colleagues also joining today's presentation. So the title of today's presentation is to Echelon VRP for agricultural area mapping operations, and we are applying it with the consideration of doing this operation using drone. So today's the presentation divided into 4 sections, like we used to put in the paper: introduction, problem description, computational study, and conclusion and future research direction. So basically, I'm adding this video to the presentation. I'm hoping that this can introduce the problem well. So if you could not heard the voice from this video, please inform me through the chat feature of this Zoom. Okay, let me start.
Welcome to the new digital agriculture workflow, integrating multiple pieces into one solution for smarter and more sustainable farming. Today's farm decisions need to happen in an instant, with the right tools and data when and where you need them the most. Pix4D technology harnesses the power of drone and sensor solutions to make operations and data gathering as simple as possible. Drones are tools that address multiple fields of application, including crop scouting and analysis through to damage reporting and variable rate mapping. With our technology, digital mapping gives you better insight into your crops from above and serves as the foundation for your groundwork. Pix4D's software solution for agricultural mapping, Pix4D Fields, is central to the workflow of farmers and service providers working as a toolkit, which evolves with our users' needs to improve farm productivity and potential. With decisions being made in field, Pix4D Fields can help you go from images to insightful maps in an instant.
Okay, so I guess I hope that can introduce you well to the problem that we are working on here. So basically, most operational decision that is being made today, it's need to be fast. It's also including the decision in the agricultural industry, in which we are specified in the mapping operation decision, in which this kind of activity can help providing data to the farmer or to the decision maker regarding a lot of things in the agricultural industry, such as decision on what the result of the mapping operation could be used for the, let's say, decide when you need to put the fertilizer or the pesticide for the animal that perhaps can reduce the yield of the farm. So basically, this kind of research is belongs to precision agriculture that mostly aim to use as minimum as research as possible to increase the productivity as much as possible. But again, the technology being used for this approach, especially for the mapping operations, it's not cheap, especially if you want to map for a larger area that might also be separate in several locations. Since the one that you see in the video is like they are using personal drone, but personal drone will be only limited to several distant range coverage. Meanwhile, if you want to use the more expensive, a bigger drone, that could be cost you a lot, much more than the personal drone. So mostly we are trying to how could we increase the coverage of the personal drone by adopting the concept of routing problem for taking the drone to the site that they are going to map somehow, as simple as that. So uh, we're trying to see the area of the mapping as we're trying to separate the how to say the the area of transportation for drone, in which as a airspace area, and then for the ground vehicles, or like in the video would be a truck, as a ground space area. And since we are making this consideration, we can see that this problem could be seen as a two echelon routing type, as a VRP variance of the variance of vehicle routing problem. But this type of research has been done by many researchers, based on our literature review, which mostly considered as two echelon vehicle routing problem. It's just somehow the two echelon vehicle routing problem that are available in the literature is mostly addressed for the commercial type of routing problems, which they may be applied for the like delivery of package, or well, the closest perhaps, like when Amazon trying to use their drone as the package delivery, it's also considered as a two echelon routing problem, somewhat like that, but and using also drone, but it's still the application is in the commercial side for mostly package distribution. Our previous research, actually, yeah, it's also present in the previous section of this seminar in ICLS. We are also utilizing the same concept, approach drone to do, but that one for mapping in the disaster events. And we see that the application is not only for those disaster and natural disaster events, provide the mapping informations, but we can also apply it for the doing this agriculture area mapping. And my student is working as a surveyor, so today he assigned to a site that is to do this type of application. So I think he will be more interested on this application of the VRP. So we try to give him this topic, and then I think we got several data, and we applied. Actually, the model is not modified too much from the two echelon vehicle routing problem. It's just that in the second echelon, instead of doing routing for the drone to do the mapping, it's only an assignment in which they need to from the mapping location, the drone will go back and forth before they go to the mapping point, and then go back to the original mapping point that they conduct, that the truck or the motorcycle stop for launch the drone. So basically, the difference between this application for the commercial and for this mapping operation is that instead of we are trying to minimize the cost, here we try to minimize the total operation time, in which consists of three parts, which the operation time to do the routing, visited the mapping or launch drone launching site for the mapping area, and then the travel time from the launch site to the mapping area of the drone, so it will be in the second echelon, and then the time that is needed by the drone to map those particular area. And however, this research is actually still in underdeveloped research, and it's not yet finished. We try to well, for those model, we already tried to apply it for a small case instances, and we're seeing that this as since this is a vehicle routing variance, and we think that this would be difficult to to solve this using just exact approach or mathematical programming approach. So that we try to implement a simple meta-heuristic algorithm first, in which here we select simulated annealing algorithms. and basically we have a well-developed framework for this one. It's just, however, the simple application of simulated annealing that applied by for this case. As you can see here in the computational experiment, even though the number of nodes is not big enough, like only the most is just like 25, but here our application of the meta heuristic is not quite perform well, I think, compared to the exact solution approach. Okay, so I think that for this research first, at least we already tried to apply the mathematical models to use as a decision support for the decision maker for to do the mapping operations. It's just, however, for a larger size instances, I think we need to reconsider our application of meta heuristics and try to improve it more and try to have a better performance for those meta heuristic algorithms. Yeah, I think that's all from my presentation today. It's not a long presentation. I'm hoping to have a lot of to have more discussion and then comments and suggestions from all the audience. So thank you very much. I will return it back to the chair session to Professor Vincent. Okay.
Okay.